another video. I am from Sri Venkateshwara College of Engineering and my USN is 1VE23IS044 and I am studying 4th SEM under the Department of Information Science and Engineering, and today's subject is Discrete Mathematics and its code is BCS405A. And my topics for today's video is combinations in discrete mathematics, understanding counting principles and techniques. And my video contains introduction to combinations, fundamental principles, combinatorial formulas, applications of combinations. Introduction to combinations. What are combinations? Combinations refers to the selection of items from a larger set where the order of selection doesn't matter. This concept is essential in discrete mathematics, facilitating calculations of various selections, arrangements, and grouping possibilities within a defined set. Basic concepts, notation and terminologies. In combinatorics, combinations denoted the selection of items from a large set without regard to the order. The common notation is NCR or C of n comma r represents the number of ways to choose r elements from a set of n elements. Understanding this notation is essential for analyzing combinatorial problems. Factorials and their role in combinations. Factorials are fundamental in combinations, representing the total arrangements of a set. The number of combinations of selecting R items from N is calculated using NCR equals N factorial divided by R factorial into N minus R factorial, highlighting the significance of factorials in determining distinct groups. The binomial coefficient. The binomial coefficient, denoted as C of n comma k or n chooses k, calculates the number of ways to select k elements from a set of n distinct elements without regard to the order of selection. It is central to combination and it is expressed as C of n comma n equals n factorial divided by k factorial into n minus k factorial. Fundamental principles. The fundamental counting principle. Definition and example. The fundamental counting principle states that if there are m ways to do one thing and n ways to do another, then they are m divided by times of n to perform both actions together. For example, if there are 3 shirts and 2 pairs of pants, there are 3 divided by times 2, that is 6 outfit combinations. Application and combination. The fundamental counting principle states that if one event occurs in m ways and a second in n ways, the total combinations are m times n. This principle is essential in analyzing combinations such as determining possible subsets or adjointments in set theory. The rule of sum and the rule of product. Explanation for the rules. The rule of sum states that if there are multiple ways to perform tasks, the total number of ways in the sum of individual options. The rule of product indicates that if tasks can be done sequentially, the total combinations equal the product of ways to perform each task. Example for applications. The rule of sum states that if there are multiple ways to achieve an outcome, the total is the sum of those ways. The rule of product states that if tasks are sequentially performed, the total outcomes are the product of the ways of each task. For example, choosing an outfit involves multiple shirt and pant combinations. Combinatorial formulas. Binomial theorem. The overview for this theorem. The binomial theorem provides a formula for expanding expressions of the form a plus b all to the power n. It expresses the expansion as a sum involving binomial coefficients, which represent the number of combinations of n items taken k at a time, illustrating the relationship between algebra and combinatorial counting. Applications of binomial coefficients. Binomial coefficients, represented as C of n comma k, count the ways to choose k items from n. They are crucial in probability, combinatorial identities, and polynomial expansions, enabling application in statistics, computer science, and combinatorial optimization via the binomial theorem. Combinations with restriction. Types of restriction. Types of restriction in combinations include inclusions requiring certain elements to be included. Number two, exclusion, preventing specific elements from being selected. Third one, cardinality, limiting the total number of selection. Fourth one, grouping, mandating certain elements to be chosen together or apart. Calculation methods. Combinatorial calculations with restrictions involve techniques such as principle of inclusion-exclusion, generating function, and recursive method. These methods help counting for limited options or specific condition, ensuring accurate content and combination problems. Applications of combinations. Real world applications. Combinations and statistics. Combinations play a crucial role in statistics, particularly in determining probabilities and making prediction. They are used to analyze sample spaces, design experiments, and conduct surveys, allowing statisticians to calculate possible outcome and make informed decisions based on limited data sets. Combinations and probability. Combination play a crucial role in probability, helping to determine the likelihood of various outcomes. For instance, in lottery games, the number of ways to choose winning numbers without regard to order illustrates how combination influences probability calculation, directly impacting strategies for playing. Advanced topic, combinatorial design. Combinatorial design is a field that uses combinations to arrange elements into specific structures, facilitating experience and service. It helps ensure balanced representation and reduce bias, playing a crucial role in statistical analysis, scheduling, and resource allocation in various disciplines. Combinatorial games and strategies. Combinatorial games utilize combination to analyze possible moves and strategies. Player assess positions by calculating move outcomes, employing combinatorial techniques to optimize their playing games, ultimately leading to winning strategies in various scenarios like NIM and chess. So that's all, folks. Thank you for your cooperation, gratitude in every form. So keep watching my videos, and I'll be getting you like this interesting and exciting learning videos. And signing off by Roshni Pian.